And so I see a lot of folks pointing out, well, they're all things that we use for coding. A lot of them have apps associated with them or use apps in some way. A lot of them are free. A lot of them are easy to use. Most of those are block coding tools, and some people are pointing that out. And then I do see a couple of people point out that those are mostly visual tools. We talk about some of these things like Scratch, Java, Python, code.org, Make Code. Most of those, all of those are tools that we primarily interact with visually. We're seeing what's on screen, we're seeing what we're manipulating as we use it. And then in a lot of cases, we're seeing the results of that code play out as well. So that's the direction that we're gonna go in taking a look at this today. Statistically, what we see is that around 1% of the coding community globally has a visual impairment, with about 1 in 20 identifying as blind. Those numbers are really similar to the numbers that we see in the overall population. So people with visual impairments are working in the computer science field, but many of the computer science programs that we have in place in schools are not as accessible to our visually impaired students. And so that's something that we're going to be taking a look at today. We're specifically here to take a look at a tool called CodeJumper. CodeJumper is a physical coding language. It's based on block coding, like things like Make Code or some of the code.org programs or Scratch. But instead of interacting with blocks of code on screen, the students code by connecting different physical pods that are acting as the physical blocks of code. The output is typically sound or music. So it's not necessarily relying on visual input or output to interact with the coding that's happening. And we're going to be exploring it. We're going to dig into it a little bit, see how it was put together, why it works the way it does, how it's used, and we're going to attempt to do a live demo on Zoom, and I think I'll be able to make that work. So I have a video that I want to share to kind of give us some background. And once it starts playing, if, as sometimes seems to happen with Zoom, you're not able to hear it, somebody let me know right away in the chat and I'll make that adjustment.
Row, row, row your boat, twinkle, twinkle, little star. Helen's story.
All different strands of code 9-year-old Joshua Lewis has pieced together using CodeJumper.
I have to loop around here.
By plugging together small pods, Joshua is learning the basics of computer coding. Something that is fun, but also puts him on a path to reach future goals.
I could probably maybe go on the internet one day and program games and create new games, and maybe program robots to do different things.
Joshua has some big dreams that can't happen without coding.
Maybe invent self-driving cars when I get a lot older. Some stuff I want to invent now.
Plug by plug and sound by sound,
I want to do a pod.
he's getting closer to his first big invention.
Half a beat.
CodeJumper is a physical computing language that is based on block coding, but it's been taken off the screen and put physically on the desk in front of students.
Robin Lowell at TVI developed the teaching curriculum that comes with CodeJumper.
Watching a student use CodeJumper for the first time is an amazing experience. So the kids, they just want to dig in from the second they lay hands on it, and you can see those little wheels turning in their mind and this problem solving and what ifs.
Robin says all students should have the opportunity to learn how to code.
There are so many other skills built into it, such as computational thinking, problem solving, and collaboration, that students need to learn these skills from an early age to not only have the skills to move forward to other text-based coding languages, but also understanding that this is something they can do from a young age.
Maybe we should try it?
Skills that all students can learn together.
This is a loop pod you see right there.
Every student in the class has the opportunity to fully participate in the experience that the teacher is providing.
Something Joshua's dad, Darren, is grateful for.
The ability to learn and to do things that other kids get to do it's a joy. It's a joy to watch his face light up when he plays with these things, and to have him talk about what he wants to do in the future is all amazing.
He knows that accessible innovations like Code Jumper will break down barriers for young people who are blind or visually impaired.
Joshua wants to be an inventor. He wants to invent flying cars one day, and the next day it may be a way for him as a visually impaired person to be able to fly an airplane.
And as long as tools like Code Jumper are available, Darren has no doubt Joshua can build his inventions.
Our hope is that he will be able to do whatever he puts his mind to do.
Visit codejumper.com to learn more.
Row, row, row your boat.
It's always interesting, I think, to be able to get to see firsthand the impact that a tool is having with a student, and some examples of how they're interacting with it. So love that video. I think it's a good way to start things off. A little bit of background about where we're coming from. The Code Jumper tool was designed by Microsoft and developed by a company called APH that was brought on board by Microsoft to do that. It's being distributed internationally by Humanware, which is one of the leading assistive technology distribution companies. And although there's a physical tool, it does require a computer to run. You do have to use a Windows computer because it's a Windows app that connects to the Code Jumper kit via Bluetooth to make it work. And I'll kind of show you how that works when we do our demo here in a little bit. But I want to pop open the Code Jumper website here on screen and kind of show you some of what's available there. And if it's something you want to look around at, it's just codejumper.com, so easy one to get to. The website has a description, some background about the tool, tells us a little bit about why they're doing what they're doing, and it actually has that video that we just featured. The About section shows us all the different pieces that come in the kit, and we'll open up the kit and go through that together. And then it has some interesting testimonials, something nice to get to see and be able to pull out and use. But what I wanted to show you is the resource section. The resource section has a link to the Microsoft Educator Community course. It has a copy of the user guide available both PDF and HTML. Some assessments, some tutorial videos. The tutorial videos are really good. A lot of tutorials you can also find on YouTube. A lot of folks have put things together to help you be able to use this tool. But then a really great resource they have here is these Code Jumper lessons. They have a set of 19 lessons divided up into primary and advanced that are ready to go, that teach a lot of the fundamental computer science concepts that we get to through all of the other tools that we use in teaching computer science. So you'll see the computer systems, sequences and algorithms, parameters, threads, debugging, loops, decomposition, constants, conditionals, random variables, nested loops, networking, all of the same basic concepts that we try to teach through all of the other computer science tools that we use are available through Code Jumper as well. And so they provide those lessons to make sure that any teacher who has access to the tool has the ability to use it. They don't necessarily have to have a strong computer science background or experience in teaching computer science to be able to jump in and use Code Jumper in the classroom with students. So I do have another video that I want to share that takes in a little bit of the background about Code Jumper and shows you some of what's going on. So again, if there's any problem with the sound, please let me know in the chat. I'll get that taken care of immediately.
Project Reno is a physical programming language that allows children ages 7 to 11 who are blind or low vision to access the computing curriculum.
Students learn if I take this device and plug it into this device and plug it into the hub, that creates a loop. It could be music, so they may be able to loop a couple notes together. They can create a repeat, they can add additional notes. The possibilities are endless.
The huge benefit of Torino is it's a physical environment. The students can actually touch and manipulate the different elements that make up the programming environment.
Each pod is a statement in your program. It's one line of code. And you then put those pods together to create those lines of code in your program. Many of these kids come in with a whole set of skills ripe for computing.
Yeah.
And we just need to give them the tools that allow them to grow that talent.
Programming is an ideal potential job opportunity for visually impaired people. They actually make up approximately 1% of the programming community worldwide.
It's either the top one or the bottom one.
It's the bottom one you need to change.
It's an environment that will work for any student that is a tactile learner. Because it's accessible, it allows you to immediately engage with the concepts of programming. It allows you to immediately create programs that work.
If this one was on 8 and that was on 1, this one would play because the number is higher.
Particularly in this case where there's quite a specialized market, we needed to partner with someone who really understood that market and really understood how we would get a quite advanced technology into the hands of the kids that it would be most impactful for. APH know how to do that.
Microsoft handed us this project name of Torino, and we decided on the name Code Jumper. And they said, take all this research and time and energy and money we've spent and help us get this into the hands of students and be a partner with us.
Our hope is that we inspire all blind and low vision children to code regardless of where they are.
I think we only need 2 because then the next one there's more than 1 note.
Yes.
Then we put a pause in between.
Yes, that's fine.
There's been lots of light bulb moments where they've suddenly understood a concept, where they've been able to track through the program physically as it's running. So they've been really enthused about Project Torino. And as a teacher, that's what you want to see in your students. You want to see that level of enthusiasm to learn more.
It is an active, hands-on learning, hitting at those most concrete and operational levels for a student. And I think it's just the beginning of what's to come for this field.
Now, obviously, ideally, this is the kind of tool where any training that we were doing with it would be in person. You'd be able to get your hands on it, manipulate it, and use it. We're not obviously able to do that today, but we will be, as I said, doing a live demo, so you'll get to at least see how some of these things work together. So think about what we see in that video, and then starting to think about the implications and the applications of a tool like Code Jumper. You know, Code Jumper is not only for students with visual impairments. It can be an exciting, tactile way to get all students interested in learning about coding and learning about computer science. Computer science is for all of our students, and Code Jumper is designed to try to be a tool for everyone, a tool that we can really use across the board to get kids excited and interested through some tactile manipulation of code. So we're going to try to see this tool in action here. I'm going to do a live demo of Code Jumper over Zoom. I'm going to attempt to do a live demo of Code Jumper over Zoom. So I do ask that you bear with me. It's going to take me probably 2 minutes to switch everything over to another camera that I can show my desktop on. If you've had a busy afternoon, you've been waiting for a chance to refill your coffee or this room or something, this is a good time to do that. I'll be off screen for about 2 minutes while I get this switched over. All right, I think this is working. If somebody can give me a thumbs up just to let me know that you can hear me right now. Okay, gotcha. Excellent. Thank you so much. All right, so here we have the Code Jumper kit. This is the box that it all comes in. When we open that up, you'll see all of the different pods organized in a foam case.
Hey,
And I'm going
Jeremy.
to pull it. Yes.
Sorry, is there a way to change your rotation on this?
There's not. I spent
Okay.
half the morning trying and there isn't. So you're
Problem.
going to have to deal with a sideways screen for this one.
Sorry.
No, it's fine. I think it's a consequence of the phone app. I took an old floor lamp with a gooseneck on it that broke, and I took it all apart and used it to build a big contraption to hold my phone up over the desk so that I could do this. Turn off this lamp because it's glare. Well, I'd rather you be able to see and have a glare than not. When I turn the tool on using this dial here, this is the central pod, the hub that runs everything. And this is my volume dial. When I turn it on, I have the Code Jumper app open on my Windows laptop right now, which connects then automatically to the Bluetooth on the device. And I can see the code that's there. So somebody, a teacher or another student who's working with a visually impaired student would be able to see what was going on there on screen, but that's not where the important parts of this experience are coming from. As I start to open it up, I can pull out different pieces, and I see that we have different pods that have a different look to them, different knobs, wires, controls, and things. They all look different, they're color coded different, but more importantly, they all feel different. So I have a pod here that I see has two knobs, one that has 2 spokes on it and one that has 3 spokes on it. Very easy to tell them apart. I have a pod with 2 wires and 1 dial. A pod with a wire and a dial on it. Another kind of pod that has a wire and 2 different kinds of dials on it. So all of these feel different in your hand. They move differently and can be manipulated in different ways. And the best way to get started with something like this a lot of times is to start putting things together and see what happens. And I can see if I take this blue piece and I plug it in.
No code to play.
And press play, it says,
no code to play.
No code to play. So as this is set up and plugged in right there, it's not doing anything. So I can experiment around a little bit more. All right, well, what if I plug in this yellow piece? And I heard a little click. And it gives me a little burp that just sort of means there's an empty code there. Well, what if I plug the blue piece into that?
Three, 4, 3, 2, 1, 8.
As I turn this dial, I hear numbers changing
2,
there.
3, 4, 5.
And then this has another wire coming off of it, so maybe I'll try connecting that there. I'm worried that there may actually be a problem with that pod because it's not doing what I expect it to. So I've connected this one in its place.
Twinkle, 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 twinkle.
When I press the play button, I get a sound repetitively. Let me try manipulating a few of these knobs and we'll see if you can kind of tell me what you think is happening here. If I turn the knob on this yellow piece.
5, 6,
7, 8,
1, 2, 3.
As I turn it, it states out some different numbers. On the blue pod, if I turn the low dial.
Twinkle, little star, twinkle.
Every time I hear it, it's changing the sound. And if I turn the other knob.
Twinkle, twinkle, twinkle.
When I turn it, it's changing the speed of the sound. So this one's selecting it, and this one's changing the speed of it. Now, if I press the play button on the hub, so the question is, what do you think this yellow pod is doing? What do you think the purpose of this pod is? A number. How many times is it going to run that block? Does anybody know in coding and computer science, what do we call that when we have a piece of code that decides how many times another piece of code is going to run? It's a loop. Yeah, thank you, Brian. Byron, I'm sorry, I'm looking at another screen across the room here. I'm trying to go back and forth. So this is a loop. So that's one of our basic pieces of coding, something called a loop. So I can turn this
4, 5,
and I don't have to see anything
6,
on screen
7,
to know that I just set that to repeat this 7 times.
Twinkle, twinkle, twinkle,
And I can hear the change it's making when I manipulate this blue pod. So
twinkle.
if I've selected that sound and I've asked it to play 7 times, when I press the play button, we should hear that sound 7 times.
Twinkle, 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 twinkle.
And then that's exactly what happened. So we can then, let's go ahead and connect. We have our loop, and it physically comes out as a loop. We can follow our code by following the wires in the pods. The wire comes out of the hub, goes into this pod, and loops through it and anything that's stuck there. And then it'll move on to anything we connect after it. So let's see what happens then. This should come next in line. Let's see what happens when I press play.
Twinkle, 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 twinkle.
So it looped through this 7 times, and I'm going to turn that down.
4, 3, 2, 1, 2.
Let's set it to 2 times.
Twinkle, 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 twinkle.
And normal speed. And so this is set to loop the first twinkle 2 times and then move on to the second twinkle. And let's see if it does that.
Twinkle, twinkle, twinkle.
So that works. Now, part of how this is laid out is it gives us 4 inputs on the hub. And those will work sequentially, so that if I then plug in a sound into the second one,
Twinkle.
when I turn this one, I'm getting different percussion sounds, different drums and cymbals. And on screen, I can change the sound bank that they're working from. By default, when you first turn it on, plug it in, the first one plays Twinkle, Twinkle, Little Star. The second one is percussion sounds. The third one is cowboy sounds. And the fourth one is animal noises. So we'll look at how those work together. And by default, it's going to play whatever the program is off of this first connection, and then move into the programming off of the second connection.
Twinkle, twinkle.
Sorry, I lied to you. It's going to play each program at the same time. And there's a way to change that. But right now you'll hear, since this is set to a cymbal crash, you'll hear on the first time it plays the first program, it's also going to play that cymbal crash.
Twinkle, twinkle.
We could, if we wanted to, put a loop on that. Take our loop piece. And see what happens when we run both of those at the same time.
Twinkle, twinkle, twinkle.
So you can see also a wonderful tool for letting students torture anybody who happens to be around if they want to set a symbol on 8 times loop. One of our other main pods that we have here is this orange one with a single dial on it. What this is a pause. So we can put that anywhere that we want to put a pause in our program. So now instead of that symbol going 8 times in a row, we'll get the symbol and a pause, and then that will loop 8 times in a row. So that symbols should be, and I'm turning that down to 4. Let's see what that does.
Twinkle, twinkle, twinkle.
And students can play with that idea of the symbol crash then getting further and further apart by depending on how long you put a pause in for. The third one, as I said, and it does take a minute for the Bluetooth to register the changes, so
no code to play.
Bear with it for a moment while that loads. Let's see what the cowboy sound does here. So it's playing this sound, pausing, looping, playing the sound, pausing, looping, and it played through that 4 times. And we can connect that same code to animal sounds. Played the sound, pause. Now I'll press the stop button here so that we don't have to listen to that pig squeal the entire time we're talking. But as it plays through these different loops, it has certain sound banks that are built in. But as a teacher, you have the opportunity to, let's say you have a song that you use in your classroom to teach something. You can record the snips of that song. You can record each line of that song with using your Windows computer into the Code Jumper app to create a new sound bank, and the student can then remix that song, remix the class song, or a certain set of sounds that you use in your classroom for something, and then the student can manipulate that set of sounds. So you're not stuck with just what's included already by default in the kit. It does give you the opportunity to go ahead and add anything that you would want to on your own. It also has, and you do have to access the screen to hit this command, but it does have a built-in screen reader that reads the code as programmed. I apologize. I was trying to demonstrate the screen
Pause
reader.
for 2 beats. And loop. And 3.
I'm having a major issue with the Bluetooth on the Windows computer that I happen to have around. So let me try that screen reader one more time and see if it works correctly this time.
Red for animals. Loop 4 times. Play pig for 1.
I apologize. The Bluetooth does keep cutting out on this computer, and it cuts out in the middle of trying to read the screen, and so it just stops doing the reader. So we're not going to be able to do that one at the moment. Let's try something. Yeah, we can take a few more minutes to demo this. It really is something that you want to get your hands on and manipulate for a while, because the more you use it, the more you notice and the more ideas you see for how it can be used. So I'm going to just put together a few blocks here to create a simple code that I can use to demonstrate. I plug these in a chain.
Twinkle.
Set the first one to the first twinkle, second twinkle, and then I put in a pause of 1 beat. And so here in line, I have the first line of the song, second word of the song, a pause, and then the third. And so let's see what that plays as.
Twinkle, twinkle, little.
And it puts that pause in there. So this is just something that students can, experiment with, manipulate, and change out some different things. And then there are a number of other pieces that work their way in to allow you to start getting into some more advanced concepts. Once the student understands how the tool works, you can start doing some real coding things with it. We have variable plugs, and the plugs can stick into the other knobs. This sets a variable. Some of these have raised dots on them that are a number. So this has 4 raised dots. So I can plug 4 in there. This variable is now set to 4. So this knob doesn't matter anymore. It's a 4. And then I can set anything else to a 4 just by putting in another blank variable, and it calls back to that variable. So what we should hear when I play this now is this twinkle 4 times, this twinkle 4 times, a pause, and little.
Twinkle, twinkle, little. Twinkle, twinkle.
Nope, sorry, I lied. You have to use a loop to use that. I forgot. It does need to work from a loop. So my variable is going to set that variable as the loop. This one sets it to loop 4 times. And then this one should call that 4 variable again and loop this one 4 times.
Twinkle, 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 little.
All right, it worked that time. And we have a number of other plugs here. We have one with a plus sign, and that would raise some value, whatever that value would happen to be. So maybe I want to set my variable to 3 here and add a plus sign to raise it 1 to make it 4 on the second time. Sorry, the computer needs a minute to process the code.
Twinkle, 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 little.
So that plus adds 1 more to the one before it. We also have a minus that obviously takes away we have a random, an R, a raised R on it that stands for random so that it can assign a random value. And then we even have one with a little infinity loop on it. So if we run that, oh, sorry, lost my Bluetooth again.
Twinkle, 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 twinkle.
The first time a student uses this, they're going to notice that they're going to get stuck in that loop because it's running infinitely and it's never going to be able to move past it into the next command.
Twinkle, 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 twinkle.
So I'll pull that out. And also there's an extension cable just in case somewhere in here you need an extension cable. Some different pieces with different functions. This one's a joiner that would bring together two separate pieces of code into one. And there are some applications for that you would see in some of the lessons as we go through. So I'm going to, let's see here. Okay, I stopped. I'm back. And that should take care of that. And to jump back over to the other screen. Okay, I'm back with you. I can leave that on screen over there, but I've got the sound back on my laptop so that you can hear me here. And what I wanted to do then is ask for a little bit of feedback from you. Where would you see a tool like this fitting into what you do? Where would something like this work for students that you service? And you can feel free to unmute yourself and talk. There's not that many of us here. I don't think it's going to be a problem to manage. And I'm not talking about adding something on for the sake of adding something on. I'm talking about where can you see this tool meeting the needs of a specific student or of a group of students? Where could you see it filling a gap that you've seen? Where could you see it supporting standards or providing opportunities that otherwise might not be available?
So I teach at an online school all the time. So I see that this could be used to accommodate students with visual needs, at our school. So I think this will be awesome. It is a STEM school, so I think it would be completely applicable for those students.
Yeah, very cool. Great idea.
Where do you see this bridging into actual coding?
That's a good question. The fundamental thing that we're looking at is once students understand how to manipulate these different pieces and put them together, we can bridge that very easily into explaining to them the coding aspects of what they're doing. When you set that yellow pod to make something happen again and again, that's a loop in coding. When you put in the yellow pause pod, that's the same thing as putting in a wait command in Scratch. And I'm flipping through here to we have a selection pod that's on both screens. That's this one with the two green dials, and the selection pod is an if-then statement or an if-else statement in coding. And so each one of these pods corresponds to one of those lines of code. It's one of the fundamental things. These purple ones that have the numbers or the plus signs, etc., on them, so those are constants, whereas the gray plugs that they plug into represent variables that we set with the first one and then call with any subsequent gray plugs. And so all of those fundamental coding concepts are represented physically and then transferred to the computer via these different pods and plugs that we put together.
Quick question on the screen reader piece. I have tried using it with JAWS, but you say there's actual one built into it?
There is, although I appear to be having a terrible time with it today. I haven't tried to use it enough times to say whether it's a consistent issue or whether it's an issue with my Windows laptop or an issue with the screen reader in general. I'm noticing it cutting out a lot in the middle of reading codes, but like I said, I am definitely having a problem with my Bluetooth connection to this laptop. So that my best guess is that that's what's causing the screen reader to fail, is that my computer is losing its connection to the Code Jumper hub in the middle of trying to read through the code.
What I've experimented with is using JAWS and a note taker paired, turning the volume off on the computer and just using the Braille, refreshable Braille to show the code.
Oh,
that way
okay.
the sounds of the pods and the hub and everything are played without JAWS overlapping.
And that's been successful for you?
Yeah.
Awesome, good tip, thank you. Anybody else have either any experience with using Code Jumper or kind of light bulb moments where you're seeing where it could fit into what you're doing?
I have a question because I do have a kit and I haven't been able to get it going yet because of technology issues. Would it work? I thought the school has provided a Microsoft tablet. Will it work with a Microsoft tablet or does it have to have a laptop connected with it?
It will work with anything that's Microsoft. And the reason, as long as it has Bluetooth built into it, the reason for that being that the app, since the tool was developed by Microsoft, they have not yet, and I don't know whether or not they have plans to, but they have not at this time released an app for iOS or Android. So the only app store that has the Code Jumper app that actually runs the code is the Microsoft App Store. So that would be your Microsoft Windows computer or your Windows tablet, like a Surface Pro or something like that. If somebody has a Windows phone, I know they're not making those anymore, but they did for a while. If someone has a Windows phone laying around, I would be really interested to hear whether or not that's able to run the program as well. I would suspect that it could. I see in the chat, Tammy just shared a link to the system requirements with us. So if you have any further questions on what systems it will and won't work with, you have a link there that will take you right to it.
In terms of recording your own sounds with Microsoft, what is that process?
That's a good question. Let me get the other computer over here the one that's running the app. And there's one of the tabs in the app is called Sounds. I don't know if I can. No, you can't see this. The camera's not going to pick up the screen, right? And I don't have Zoom installed on this computer to add a connection. So I'll just tell you about it. In the app, which it's a very, very simple app, just a few buttons in it, I can hit the Sounds tab. And I have the option there to add a sound set. When I hit add a sound set, I can name it. Click the add button. And when I do that, it asks me to add a sound file. From there, I can just upload a sound file. I think a WAV, a wave format, would be the best option to use. So I would record those sound files, probably just using a basic sound recorder program on my computer or on my tablet. If you were looking for an easy way to do it, honestly, if I were going to do that right now, the first thing I would do is I would open the App Store on my phone and type in WAV recorder and find an app that recorded in that format. And then I could just really easily pop out recordings of the pieces of sound I wanted. And then once those are saved on your computer, you can load them into a custom sound set in the app.
Do you know if there's a limit to the size?
I don't know that. That's a really good question. I'm going to add that to my list of things that I do want to continue to research, because I'm curious to hear that now as well.
Have you found any type of auxiliary things to add into the Code Jumper set? You know, say if you added
additional lines of code, you mean?
Yeah.
I haven't. I wonder if anybody's making anything, or if there are plans to expand it. It's not cheap. I believe the overall kit is just about $1,000 to buy this suitcase size kit with the general set of code pieces. But I haven't seen auxiliary or separate pieces for sale anywhere yet. Looking at it, I see Greg Laser says they added Android compatibility to Code Jumper recently, and iOS hopefully in the future. That is good to know. I hadn't tried it with anything Android yet. I knew that it was not working with iOS. So there you go. We should also be able to use this with Android devices. I have an Android tablet on my shelf over here. I'll charge it up and give that a try, so that I can see for next time if there are any actual differences between what the platform looks like on Windows and Android, or how you use it. So that's going to give me something to test out next.
Is there a forum anywhere where you or others who are using this are updating what they've done?
As far as testing things out?
Correct, yeah.
Okay, I actually do have something for that, specifically for this group. So let me drop this link in the chat. And this is what's called a frequently asked questions, although none of the questions have been asked yet, so they can't be frequent, but we'll see as it gets frequent. It's just a blank document that I started today. I'll enter these few questions here. Any of you that have any other questions as well, and we can use this as kind of a bit of a forum as we get started, so that if you think of something, you want to see if anybody else in this group has, and I'll continue to use this document with other groups and in other Code Jumper opportunities, start building it out into a more usable database of questions that have come up. So I'll add these questions and anything else that you want to add to this, and we can set about the task of building our own for him. I didn't pay him to ask that question, but he did set me right up for that. So. And as we come up to the end of our time here together, then Avni has just dropped the attendance link into the chat. No code needed to access it. I'm going to go ahead and pop my contact information up here. Let me take back the share screen to this computer. Find that window, share. And put my contact info up on screen if you want it for anything. If you want to follow up or get back to me on any of that.
Just, I'm sorry about it. I didn't turn on the link right away. Just make sure you're refreshing your screen, and it should work now. If someone could confirm that for me, that would be awesome. Thank you.
All right. Well, thank you everybody so much for joining us for this session. I hope that it at least gave you a little bit of an introduction. Right now, there are not a ton of these kits floating around. So reaching out to your intermediate unit or reaching out to the patent office in your region, and someone may be able to put you into contact with where you can get one of these as a loaner to try out or to use and put it into the hands of a student. But please do know that we're working very hard to get these kits placed into throughout the intermediate unit system so that they'll be available for teachers to get and to use with students. We expect to hopefully see that happening in the very near future here. We'll update as that information becomes available, but we're just getting this rollout going and working hard to get them out and ready for you. So CodeJumper is in short-term loan and can be purchased using quota funds. So there you go. Thank you very much for being here with us today. Avni, thank you for running the back end of this Zoom meeting. I absolutely could not have done that myself while I was trying to manage the slides and the screen share and everything else. And so excellent to have you here. Thank you all. Have a great afternoon, and I look forward to working with you more on this in the future.